Okay, I'm going to tell about our effort. It's it is in a very early stage, so any comments and suggestions are very welcome. It's we want to enhance current streaming protocol implementation, so it would support we encountered this actually for to give a big background. We encountered when we started to find solution to improve performance of Milvus vector database written in Go. And here we saw that existing APIs or UCP APIs like Active Message or whatever didn't fit well. So we decided to try to find something which would fit better, which would perform those applications. Milvus is just that was our thought. Milvus is just an example of such applications. It's microservice. It's using microservice-based architecture. Many processes are running on the cluster, and provide this cluster is has RDMA networking infrastructure. We thought that it would be nice to make it use for it running a lot networking, a lot of networking traffic, and we thought it would be nice to make it benefit from zero copy transport. It could, if in some cases, it would improve performance just because it would give a higher throughput. If you replace, say, RDMA, currently they're using regular TCP implementation. If we replace TCP with RDMA, we could improve throughput, which could benefit from it. But even if network isn't bottleneck, it still may improve because by offloading protocol handling, network protocol handling, we would reduce CPU utilization, leave more CPU to calculation, to the rest of application needs, which also would be beneficial. Okay. Am I explaining okay?
Yes, go ahead.
Okay. Okay, so I'll start from explaining what is the idea. It's somewhat resembling. It's not resembling. Its idea is to extend traditional rendezvous protocol, which traditional rendezvous protocol is the way to allow RDMA zero copy to be used by application with itself using regular send receive. protocol. How it is done? It's let's say the most straightforward way is sender would say instead of sending data would send some data descriptor which will describe data location, remote key, provide access to the disaster, and receiver would perform RDMA read. Upon receiving, receiver would perform RDMA read from buffer on the sender side to his local buffer. This way we avoid any unnecessary staging intermediate buffers. Data is going directly from source application memory to the wire, and from the wire to the destination application memory. By the way, on the other side, it's actually the same way it would be implemented or opposite. Receiver could also provide descriptor for its destination buffer, and sender could perform RDMA write to it. It's symmetric. In case of rendezvous, it's just not very useful. But let's say, let's think of a situation where instead of two buffers, we have actually two stream objects. In other words, we don't have an entire buffer. We have some callback or some object which will provide us data in some chunks which depends on application logic on both sides. For instance, sender is processing data. Sender has performing some calculation, processing data. When data is ready, it calls us and provide us certain amount of data chunk. Receiver also providing buffer to be filled with data and supply it to some next level, some next subsystem inside its application logic, and provide us with next buffer to fill. So we on both sides we have instead of two buffers of the same size to transfer, we have constantly shifting frames. Idea is to make data transfer zero copy, and those constantly changing and appearing and buffers to coordinate with control messages. It's naturally the goal is to minimize number of these messages to make it it's costly. It's obvious that as a few control message will have, we're supposed to get a better performance. So the core idea here is that each site could be either in either in active state or in passive state. We call active state the site which is actually performing RDMA operations. If it has data, it performs RDMA operation, and if it hasn't data, if it has data to transfer, but it didn't receive data descriptor from the other side, then it decides that probably other side should take it's a time to transfer the active say token to be active to the other side. So it instead of it can't transfer, so it send control message which describe data on his side, and passive side upon receiving it turn to active side, and this may happen depending on which side has larger buffer at a specific moment. No, logic is to make the site which has larger buffer to turn to passive mode. So the site which with smaller buffers will perform upon receiving those small buffers will just issue RDMA read or RDMA write, depending whether it's sender or receiver, and will no need to do excessive control sending. This is idea. This is explanation about collision avoidance. But probably to make things more clear, I could explain, show something like protocol outline to explain, and later I will return back and explain why collision may happen, and how it how it may be avoided. Okay, so let's first case, active site. What happens when active site get control message from the passive side, which describe data, describe ARCI and data placement. No, in this case, active side is receiver side. It's right side. If queue of buffers of data, in our case, it will be buffers to be filled with data, is not empty, we take this buffer and perform, in this case, RDMA read operation. If otherwise, if we don't have yet data on our side, we just enqueue this ARCI to be processed later. Okay. When we complete to work with when we received and finalized reading of some buffer from other side, we should inform the other passive side, so it may release this buffer for reuse, so it may report to application which supplied it that it finished to handle it. Okay, when active endpoint site is inactive and it get application command, in other words, it get local buffer to be used. It's the logic is approximately opposite. We dequeue ARCI, which if we have ARCI received, let's say the one which we enqueued in case we got it and we hadn't yet data to buffer to store data or transfer data from, depending on whether it's sender or receiver. So in this case, now we have both remote script and local buffers. We perform RDMA. Otherwise, we send control buffer with description of this buffer to other side and switch to passive mode. In passive mode, it's with passive mode it's easier if stream API command we just send control message about it and queue it to the buffer. If we can get control message, it means that we should transit to active. Should queue it and transit to active, and then as an active site, we keep working just like we just received it. So we actually jump to this point. Any questions till now?
No questions yet.
Okay. So let's I explain a bit about collision. Why it may happen. Sites may, let's say, since passive site sending control message whenever it gets new buffer from the API. On the other side, active site exactly in the same time may try to send control message trying to turn passive site to active, to exchange sites. In this case, if this happens simultaneously, those messages can collide. For this, to avoid the situation, each control message also have some ACK field, similar to PSN and TCP, which indicates last received control message from the opposite direction. When two control messages are sent simultaneously, both sides will see that it will eventually happen on both sides, but they both see ACK field as outdated, not last that they sent themselves. So in this case, active site or site which was active and trying to pass is trying to move to passive site. It will return to active site and process the received message. Passive site, in contrary, knowing that message will be correctly handled, just will discard the message which trying to turn it to active site. This is the way we resolve collision.
I have a question. Maybe this is not the only possible way. Maybe it would be something else, like always prefer RDMA write always over RDMA read if we have collision.
Okay, okay. Maybe I can think about it, about positive, negative sides.
Also, more general question: does it work with multi-rail, or is there any special change needed to work with multi-rail?
Currently, as we didn't plan to do something special about multi-rail, and currently it looks like in case of multi-rail, if one of specific RDMA transaction, like on this diagram, is big enough, we will split it and send in 2 lanes.
Yeah, but with a multi-rail RDMA write, we need a fence and a specific kind of ordering, maybe several control messages. If you look at put the copy protocol of rendezvous. So something we need to consider.
Okay. Okay.
Because you cannot assume that there would be order between control messages and the RDMA messages.
No. Okay, we need to see, but at this moment I don't see where reordering is important here. It may happen here.
So the question is, when in this diagram, for example, when you do RDMA write free, and then you send control free, is control free being sent immediately after sending RDMA write, or you wait for some kind of a flash or a completion on RDMA write?
No, I guess we need to. We need to know. I guess even if RDMA write, you say that we may report that we finished, but we actually don't know whether RDMA write finished.
Yes, we don't know. We need to know for sure data has arrived. For example, currently in rendezvous protocol, in protocol V2, there are different cases that handle this. So I guess we would have to do something equivalent here as well.
Yes,
what if we send this control-3 message on the same lane as RDMA write 3? Assuming that it supports active messages.
Yeah, but let's say RDMA write 3 may end before RDMA write 2, or let's say half of RDMA write 3, upper half of RDMA write 3 may maybe let's say use another rail and finish slower. Yeah, it's a question. It's one of the open issues we need to handle.
Okay, thanks.
Just a quick question. Do I understand correctly that we don't need any API change for that? You're just describing how to implement rendezvous protocol efficiently for Stream API.
Specific this change don't need, but another way which we wanted to introduce, it's not really part of this push me pull you protocol working title, but we also want to introduce multi-channel streaming to allow to maintain multiple communication of multiple such communication inside one connection, one queue pair, and this will require a certain change in API. Backward compatible, but yes.
I have a question for Thomas. In Nickel, there is a IReceive function. It gets a list of buffers and sizes, right?
Yes.
Does it mean in Nickel, are the sizes of buffers, do they have to be equal to the send buffer, or is it possible that the send buffer would fill them partially, so we cannot use stream?
Yeah. So send is possibly smaller. Yeah.
So it's
smaller.
message based.
It's fragments, right? I think it like
So the send size is below or equal to the receive size.
it's fragmentation. They have fragments, and essentially last packet might not fill the entire fragment. I think it's 1 megabyte or something.
And it's all, and we do one receive, it's all from the same source, right? One call to I receive.
Sorry, what is?
When you do like in NickleNet plugin, when there is one I receive callback, it's all receiving all buffers from the same source or from different?
Yes, one peer, one remote.
I'm just wondering if we can plug this, because it's, remember we played with receiver-based rendezvous with Nickel, and I think you got some improvements. Question is if this could be useful. Okay, you get all those buffers, you push them, all of them to stream receive. I don't know. Maybe even to one stream receive with file vector.
You mean at the send side, merge them and send them at once?
I mean, mostly use this because we get the receiver initiated rendezvous, and in stream we have the sequence number, so to do the duplication, to solve the race condition.
Okay, do we have any more questions online or offline? Okay, if there's no questions, Artmey, thank you so much for joining and presenting.
Okay, are we finished? Or?
Are we finished, by the way? Yeah, if you're not finished.
Yes, yes, I think.
I think you wanted to mention something about the API changes.
About API changes in UCP, I have one more slide to tell a bit about integration with Go, but
okay, go ahead.
Okay. In Go net HTTP package, which is Go implementation of HTTP client and HTTP server, it's in HTTP infrastructure, it using let's say HTTP request. When it arrives, it has body field which is not a buffer but object of interface object which implements interface IO reader, which is actually stream. This about response, it's the same. Response writer, it's object which implements IO write. Actually, from this fact, we understand that we need to handle streaming. We need to work with this. With such API, we need to provide streaming API which to give which be flexible enough.
Question
Now
in which state is it now? Did you see get good performance with this? Is it You see, how does it work with existing Stream implementations?
With existing Stream implementation, it's no, it's in early stage, and in current stage, I still didn't succeeded to overpower the TCP.
With Go or with C level?
With Go. With Go infrastructure, Go framework infrastructure is. We need to find a way to efficiently work with. Still need to find a way to work efficiently with Go framework.